Good evening, everybody. I'm doing my presentation on plant rust, Bucina graminis. Bucina graminis is a fungus in the Basidiomycota phylum, and it's responsible for large damaging effects on the global wheat industry. As a fungus, when it thrives in humid and warm conditions, and has its effects on climate change has become evident. There's been growing concern over the ability for rust to take over and make an irreversible stronghold on our wheat supplies. Increases in CO2 concentrations have demonstrated that wheat biomass growth and Picina graminis characteristic change may be and may enable rust pathogens to increase their spore occupying space. Introduction. There are many numerous ways climate change is affecting the planet. There's also many ways that it's contributing to the way living things behave and operate. As CO2 increases in our ecosystem, greenhouse effects are capturing the solar radiation and continuously increasing our CO2 concentration levels. Strange rain patterns, droughts, increases in surface temperatures are becoming more common and are changing our agricultural industries. They're, they're in many species of plants, they're causing a lot of changes that have to do with reproduction, their reproductive cycles, and their ability to mate. Um, we realize that we realize that climate change is affecting the way and the rates at which organisms coexist. We're learning that CO2 gases in our atmosphere are indirectly related to the possibility of rust dominance within our wheat fields. A potential risk has been recognized. Climate change has a potential to increase crop loss due to new rust pathogens, faster evolving phenotypes, and increasing biomass of wheat crops that grow in areas where there may be higher concentrations of CO2 gases. As a result, we need to, as a result, weather patterns are changing, are making irregular changes in our agricultural practices. For example, um, UG99 is an incredibly threatening pathogen that can affect our wheat supplies, and if it continues to evolve and our wheat will no longer be resilient to it, it's going to cause a big catastrophe in our wheat industry, including a loss of up to 10% of Asia's yearly yields. When concentrations grow, plants display higher biomass production and in some cases higher harvests. So with a higher concentration biomass, but with higher biomass, plant biomass, rust has a potential to increase their reproduction. It's not impossible or a long shot for us to expect the rust to completely annihilate our wheat industry. The mutation is right around the corner. We have to start understanding how plants' immunities are evolving and not just the pathogens. We need to understand our plant resistances and how they're gonna be how are they gonna expose themselves. And we need to focus our science studies and agricultural studies on gene resistances. We already know that the pathogens are evolving quickly. They're and we already know that climate change is increasing the size of our biomass. However, we are not ready for the increase in rust, having the opportunity to keep on reproducing on the biomass that's being produced, we are going to be seeing a dominance of rust because it's going to evolve faster than the plants can resist. In conclusion, we need to understand that CO2 is changing plants, it's changing their anatomy, it's changing their gene expressions. We need to understand how increased CO2 gases are going to change their resistances. We need to start, we need to continue focusing on methods that help us with breeding. Preemptive breeding is anticipatory breeding patterns, programs that help us anticipate which crops are going to be a threat. I'm sorry, which viruses are going to be a threat to our crops. Also, marker assisted selection breeding. MAB is a breeding method used to leverage DNA markers to identify desirable traits. Clone resistance genes in cassettes of linked transgenes and novel genes develop transgenic plants with various rust-resistant genes in one locus. So basically, rapidly evolving rust phenotypes can quickly invade and dominate a crop. It is beneficial if we focus on multiple effective and resistant wheat genes, not just dominant ones. We need to focus on multiple effective and resistant genes. And that is how we can combat the invasion of rust.